Let us begin with the topic of vectors. Now here we have to understand two fundamental terminologies, that is scalar and vector. Now what is a scalar? Scalar is that quantity which has only magnitude. So in other words, it is sufficient to specify only magnitude to describe a scalar quantity, whereas a vector is that quantity which has magnitude as well as direction. So that means we need both magnitude and the direction to fully describe a vector quantity. Some examples of scalar quantity from the physical world are, say, mass or temperature or volume and so on. Like when I say the temperature is say 25 degrees Celsius, then that's it. Like it completely gives us what is the meaning of that. We don't need to specify whether 25 degrees Celsius is in the direction of north or south and so on. That is, the direction does not have any relevance in case of a scalar. Now in case of vector, it has a magnitude as well as direction. So we need to specify both to fully describe that quantity. And the example of that would be, say, velocity, force and so on. Just to make a clear distinction between the words velocity and speed. See, by speed we mean a scalar quantity, that is just the magnitude of some moving particle or object. But the term velocity is used in the vector sense. That means it also includes a direction in it. Right? So let's go ahead and see different types of vectors that we will be studying. So here are first four types. The first is equal vectors. Now we say that two vectors A bar and B bar are equal if their magnitudes are equal and their directions are equal. So as an example, let us show the two vectors like this. Typically a vector is denoted as shown here, that is small letter and a small bar over it. So here we see that both A bar and B bar are having the same magnitude, that is the length of both the arrows is same and they both are pointing exactly in the same direction. Now in case of like vector, it just means that their directions are same. Right? They may or may not have the same magnitude. So as a general example, you can have a bar like this and B bar like this. So A bar and B bar are like vectors because they are pointing in the same direction. The collinear vectors means the lines containing two vectors are parallel to each other. So for example, you may have A bar and B bar like this. So if you imagine the line along which A bar is lying and the line along which B bar is lying, you see that these two lines are parallel to each other. Okay, so therefore they are called as either parallel vectors or collinear vectors also. Right? In case of null or zero vector, it's clear that the magnitude of the vector is 0. Okay. Let's move on to next few types. Unit vector. The word unit means 1. Okay, so here by unit vector we mean magnitude of the vector is 1. Right? And we denote the magnitude as we write the vector within two vertical bars. That is the symbol for magnitude of a particular vector. So if magnitude of some vector is 1, then we call that vector as a unit vector. Next is free vector. By free vector, what we mean is, suppose we have some vector A bar, then you can shift it to some other place but keeping it parallel to the original direction. That is, whatever was the line containing that original vector, we retain a line parallel to that. Okay, and we just translate or shift the original vector to another location. That is called as a free vector. So the vector which can be shifted to another place without having any effect on its result, that is called as a free vector. On the other hand, localized vector is that for which the point of application, that is the starting point where the vector is acting, that is important. And a very typical example of localized vector is a force, because Force is a vector, so it no doubt has the magnitude as well as direction, but we also need to specify the point of application of force, because that will make a difference. That is, if you change the point where the force is acting, it may produce different result, right? So therefore force is a localized vector. In mathematics we will be mostly dealing with free vectors, so we'll be free to move the vectors parallel to themselves anywhere in the three-dimensional space, right?